So, okay, hello, Leonard. Thank you for taking your time. We will start the interview right away with the first question. I want to ask you to introduce yourself and your current role at Supply Chain Data Analytics, and please explain how your work relates to AI, supply chain management, and ecological sustainability.
Yeah, I'm an industrial engineer and I founded Supply Chain Data Analytics roughly 2.5 years ago. It's a platform that's supposed to connect analysts, operation research experts, and data scientists with people that are in need for these kind of experts, with a special focus on supply chain optimization and factory optimization. So projects that we, for example, work on are supply chain network design, supply chain network optimization, but also, for example, production planning, inventory planning, forecasting, and also optimization. So, for example, scheduling, dispatching, routing algorithms, these kinds of things. On the other hand, I'm also working for a company called Amova, which is a German company that is specialized on material handling equipment for heavy load industry, so steel making industry, for coil handling, steel coil handling, but also air cargo and container terminals. So here I am a simulation engineer and I develop simulation models using discrete event simulation modeling to design and optimize, for example, container terminals and mainly high bay storage centered solutions. And here I also, in this role of being working with my platform Supply Chain Data Analytics, and in my role as a simulation engineer, I use artificial intelligence in a more supportive role, and that it supports my simulation work. I use it on the one hand to be able to extract more information out of simulation runs that I already ran, to also infer results to a wider solution space, so to, for example, layout variants that I have not simulated. And I will probably have the opportunity to talk more about that later on in the session. And I also integrate artificial intelligence in the form of reinforcement learning into simulation models. So I think reinforcement learning, neural networks, that's something that is equivalent to, for many people, somehow equivalent to artificial intelligence. And those would also be these two areas that I'm working with in my current role, and where I see a potential to also improve the application of discrete event simulation by also making use of artificial intelligence. And with regards to supply chain management, I mean, the platform itself here, I said we work, for example, with supply chain design projects of supply chain network optimization. As one example, this is, of course, an area that is directly attributed to supply chain management, but then there's also the topic of high bay storage solutions, which I'm optimizing in my role as simulation engineer. And here, I mean, the role of high bay storage solutions is critical, for example, in industries like container industry, or in general for warehousing, as it provides a lot of storage space on very narrow surface area, and also provides direct access to the cargo, or to the goods that are stored in the warehouse. So, for example, in a container terminal, you will achieve much higher throughput because you will be able to access each container directly in the rack, instead of having to reshuffle containers in the container yard, where the conventional approach is to stack containers on top of each other. And in a factory or in a warehouse in general, using a high bay storage, you have more storage capacity on narrow surface area. So overall, designing high bay storage solutions in a way that they become more competitive helps supply chains become more efficient in the form of more efficient storage solutions, more efficient use of storage capacity, higher throughput, shorter lead times, higher productivity, And in terms of sustainability, it helps by, for example, reducing the footprint. Or other topics would be, for example, designing high bay storage management algorithms that operate the high bay storage in an energy efficient way. So one central equipment in a high bay storage is a stacker crane. The stacker crane is operating the high bay storage to retrieve and put away material in the high bay storage. And the cycle that this stacker crane drives can be influenced by a warehouse management software and the algorithms implemented in the warehouse management software. And here, using simulation and also artificial intelligence, I have the possibility to adjust these algorithms to reduce, for example, energy consumption. So that would be another example of how my current role relates to also sustainability.
Thank you very much. Very interesting. And if we go towards to artificial intelligence, you already said something about it and explain a little bit your touching points of it. And if I ask again, how important is AI for your area of responsibility? What would you say?
I mean, I use artificial intelligence as a support, like another tool in my tool set. So I think conventional approaches, as known from operations research, like optimization, linear programming, nonlinear programming, constraint programming, and also discrete event simulation or agent-based simulation. They are all very powerful techniques and methods that can solve the majority of problems that I see in supply chain optimization and in factory planning and factory control optimization. But using artificial intelligence, you can support traditional operations research and make it more powerful. So, for example, what I use is, like I said, artificial intelligence in a supportive role. That means that as depicted here in this example, I will, for example, make a simulation model of a factory, and there might be a lot of alternative variants of the layout. So, for example, you might have a layout with 20 machines, a layout with 30 machines. You might have a layout with 2 conveyor belts, one with 3 conveyor belts. One might have 3 high bay storage aisles. One might have 4 high bay storage aisles. And then there might be differences in the control logic. So you might want to have a scenario with a push control, and then you might have a scenario with a pull control in production. And then you could, of course, model every possible layout and every possible scenario to see how they perform. But in reality, that will be too much effort and will cost too many man hours, because this is very labor intensive. You need an engineer to implement all of these layout configurations and all of these scenarios. So when I see an opportunity for artificial intelligence in the area of discrete event simulation, when it comes to factory planning, supply chain planning, routing, and so forth, is to for example, train a neural network that takes in all of the layouts that have been simulated and their core variables as inputs, and then generates the relevant KPIs as, for example, production costs, energy consumption, CO2 emissions, lead times as outputs. And you can use all the layouts that you already modeled and simulated as a training set and train this neural network, fit it against this training set. And once you fitted it against this training set of layout variants that you actually modeled and simulated using discrete event simulation, you could then use this neural network to generate a forecast for how this system, so how a layout would perform outside of this training set that you actually implemented in a simulation environment. So, for example, you could then test what will happen if I have 30 machines, and what will happen if I have 10 conveyor belts, what will happen if I have a different type of control logic. And that would allow you to, as here depicted with red points, to extrapolate from a very narrow solution space onto a wider solution space, and would give you predictions of how the system would perform without having to actually model every possible scenario. And that was a lot of work. And so here I see that artificial intelligence can reduce the effort and improve the efficiency of traditional approaches as known from operations research, like for example, discrete event simulation, or also things like optimization, so linear programming, integer programming, and so on.
Okay, very interesting. Thank you. And if we then go one step further, can you name, I know you said something about before, but can you name again, please, some use cases of the use of AI in supply chain management? And maybe in a second step, also in connection with ecological sustainability, if available.
Yeah, I mean, economic sustainability, if it is in the
Ecological.
KPIs, ecological, yeah, not economical. Ecological sustainability, if it is in the KPIs as provided by the management, then any approach that seeks to optimize a supply chain or a factory will also optimize towards this sustainability KPI. So as long as in the KPIs, the analytics approach will take this metric into account, it will optimize towards it and will respect it as an objective. And like I said, so one possible use case would be if you take the example of high bay storage solutions. So storage solutions that are based on high bay storage aisles. This is something that I, for example, work with and where I use simulation and where artificial intelligence can also support simulation. There, for example, energy consumption would be one topic. So, for example, reduce the energy consumption of the stacker crane. That means that you, for example, allocate storage solutions in the warehouse based on a strategy that overall reduces the energy consumption of the moves that the stacker crane has to do inside the high bay storage aisle when operating the aisle and operating all of the inputs and outputs of the aisle. This would, for example, take the form of algorithms that select storage locations in the high bay storage in a way that reduces energy consumption. And that is really something that's also actually done in this that we try to do. So this will be one use case. And besides from them, if you, for example, look at the supply chains in general, and you do a supply chain network optimization, then you always have the question of reducing variable transport costs, which will be directly associated with CO2 emissions and fuel consumption. So these would be some exemplary use cases where you can also use, for example, reinforcement learning for optimizing dispatch decision making when dispatching trucks in a network. Yeah, these would be some examples.
Thank you very much.
Warehouse management software and dispatching algorithms for network, for vehicle routing problems.
Okay, thank you very much. And if we then talk about supply chain management, you already said something about high bay warehouses. So can you say what is the importance of these high bay warehouses for supply chain management in your opinion?
Yeah, like I also said in the beginning, the importance of high bay storage solutions is that they provide more storage capacity on less surface area. So on less space, you can put more stuff. And that means that if you, for example, think of cities like Hong Kong or other cities where surface area is very costly, then this is a very good solution because you have more storage capacity on less surface area. This is also good when you talk about ecological sustainability. It's good for the environment because you need to occupy less surface area to realize your project. And for example, in container terminals, the conventional approach is to have a block storage. So you put the containers on the ground. You maybe stack them up to maybe 7 levels. So you maybe have 7 containers stacked on top of each other. But that's then really it, and it occupies more surface area than if you put a high bay storage there. If you put a high bay storage there, then you will have much more storage capacity on the same footprint, or you will need a smaller footprint and you will still have the same storage capacity. And the other thing is then that if we talk about container terminals, they of course have a huge impact on supply chains in general. If you have a country that has a lot of container terminals, and these container terminals, they are very productive and they are very efficient, then you will have in general lower export costs and lower import costs. So your country, your economy in general will be more competitive because you will be able to import at lower cost, and you will also be able to export at lower cost compared to your peers. So every nation should be interested in having very efficient container terminals. And here, hybrid storage solutions are a novel approach. It's not been done before. It's done now by the company that I work for, Amova, in collaboration with DP World, resulting in a joint venture called Boxbay. And with the hybrid storage, you here have the possibility of also increasing productiveness, because you don't have to reshuffle containers at the container yard. You don't have to take containers away because you want to reach a container at the bottom of a stack, but instead you can access each container directly in the high-bay store. And in that way, you will have a higher productivity, higher throughput, and the ships are going to stay in the harbor for a shorter amount of time. So you can process more ships in less time if you use a hybrid storage solution correctly in the container terminal. So, and thereby you will have a more efficient container terminal, and that will also have impact on the entire supply chain that is built up around this container terminal. So that would be one example.
Thank you. Interesting. And then maybe if you talk about environmental sustainability, maybe a few words. So what would you think, how important is sustainability in your area of responsibility, and how, from where come this importance, which is it from the management, or how do you think, what is the importance of sustainability in your area?
Yeah, I think in general, sustainability will be one of the very important topics in the future. So I think supply chain design, supply chain network design in general, projects will currently always have some sort of environmental aspect incorporated into the KPIs, and in the future this will be expressed even more. So there will be an increased focus, or the focus on this will be emphasized more in the future on sustainability. But in the end effect, the sustainability has to be reflected in the KPIs of the client. So if, for example, a client comes to us and he wants a supply chain network design, he, for example, has an existing supply chain network, and he comes to us and he's looking for improvements, then the question is, what are the relevant objectives? What are the relevant KPIs? And usually it's about economic efficiency and profitability, but there might then also be something like social sustainability. Yeah? So for example, if you close a warehouse, if you relocate a warehouse, then you have to fire people, and people will lose their job, which will have a negative impact onto the local community. So there might be some KPIs that also reflect that, or some constraints that reflect that. For example, you're not allowed to close warehouses in certain regions because you don't want to have a negative impact on the community. And then in the same way, you can have constraints or KPIs reflecting ecological sustainability. So, I mean, fuel consumption in itself is also reflected in the profitability, because the less fuel costs, the lower the variable costs of the network, the more profitable it is, and also the less, the better the sustainability of the system. But the emphasis of those KPIs has to be stronger. And then, for example, if you design a supply chain, you also have additional levers. Yeah, so one would be to reduce the shipments in general, the transport distance in general, to put an emphasis on that, to reduce fuel consumption. But then you can also look into intermodal transport. So you could look to, for example, reduce air freight, reduce truckload shipments, try to ship more by rail, and try to ship more by ships. And these will then be the levers that you can work with to make a supply chain more sustainable from an ecological point of view and analytical point of view when optimizing it.
Okay, thank you. And if we now link AI to supply chain and sustainability, and if we talk about the positive effects or maybe the potential that comes along with the use of AI in supply chain management, what would you say are these potentials if we use AI? Or what is the reason why a company should use AI in order to reach ecological sustainability by using the AI in supply chain management?
Yeah, I mean, AI, I think as it has emerged, has its the motivation for investing into AI comes from that we have today usually in companies a higher degree of data, so we have more data available in general that is also available somehow digital, and also higher computation power, because I mean some of the methods, they have been existing for a long time, so it's more about the availability of data and the computational power. And what I see is that in my role, in my narrow focus of discrete event simulation, I see the potential of using artificial intelligence as a supporting tool that can be used, as I depicted here in this figure, to extrapolate from a small solution space into a bigger solution space. So this will make reduce a lot of work. I can get more results without having to model every possible layout. So this is one thing I see, the application of neural networks to make it to make a simulation study more powerful in the area of discrete event simulation. And another area of application that I see is what I depicted here. So usually when you implement a simulation model, a discrete event simulation model, the software that you use will have some kind of optimizer implemented. And an optimizer is also a tool that allows you to optimize the simulation model with regards to some KPIs that you try to maximize or minimize. So what you will give this optimizer is a list of variables and parameters that this optimizer is allowed to manipulate. And the optimizer will manipulate those variables and try to find an optimum. Conventional approaches are, for example, steepest descent optimization, factorial designs, or also genetic heuristics, like, for example, evolutionary algorithms. But with artificial intelligence, we also have now a reinforcement learning, and there was, for example, a company called Pathmind that tried to make this available for AnyLogic. And with reinforcement learning, it's more about developing a decision-making policy that at each moment in time, or for each state of a system, describes what is the best decision in the state. And this, of course, gives a lot of additional options for what you can do when, for example, optimizing a supply chain network. So I can develop my mathematical model and optimize my network, but if I use reinforcement learning, then without developing a mathematical model, I can, in addition to that, then also develop a strategy or a policy that describes how to make decisions at specific points in time or in different states of the system. So, for example, which inventory should be ordered from where and shipped to where at a given state of the system. And all of this without having to make a complicated mathematical model from an applicant point of view or practitioner point of view. And that is, I think, also a very interesting use case for artificial intelligence.
Okay, and maybe if we stay at the positive effects, if we look at logistics in general, is there, because I think you say something about route optimization. Would you say by using AI in logistics, maybe in a warehouse, um, would you say you have also like energy efficiency by having reducement of routes? Is that also a topic, or do you, or what would you say about that? If you maybe,
I'm not sure. I'm not sure I understand the question. I think if you can repeat it one more time.
so would you say that, and if we stay if we don't go too much in details, but would you say that you also have route optimization, maybe less vehicle transportation by using AI in your logistic center? Is this also a topic, or if
I
not, we
don't think
can.
you can. I don't think this is how I would state it. I would rather say that with using AI in the way that I see it from my point of view, which is the angle of a simulation engineer that develops discrete event simulation models, I see the potential of AI allowing engineers to make better models with less effort and also more powerful models. So it enables engineers to execute and deliver on studies that maybe would have taken more time and consumed more resources. So in general, it makes it more easy to execute uh, simulation studies, and thereby you of course also have a higher degree of probability that studies like that will be ordered by clients and will be executed, and that optimizations will take place, because of course if nobody takes the initiative and is willing to pay for an optimization study, then the optimization will not take place. So this is more how I would see it, that using AI, the impact and the costs become more attractive from a client point of view when considering whether a optimization project should be ordered and initiated.
Okay, fine. Thank you. And if you now look at the other side in comparison, in compared to that, um, what are the main challenges that you see for implementing AI and supply chain management in order to have an influence on ecological sustainability? What are the problems that you see?
Yeah, if you talk, if you, for example, talk about neural networks, to go back to this example that I put here, um, there the risk is, for example, overfitting. So it's there's a high risk of overfitting a neural network, because you simply put more inputs and more parameters into the model, and then it will make better predictions on the training set. So that is a risk, the risk of overfitting, which is also associated with the second risk that I see, which is the risk of low interpretability. So usually a neural network, for example, talk about deep learning, will be a black box. So it makes predictions, it makes decisions, but you don't really know why it's making those decisions and predictions. And that, combined with the risk of overfitting, of course, is a huge problem. If you, for example, talk to operation managers, factory managers, supply chain managers, they need to understand why things are taking place, and they want to understand why things are happening and why things will change. So if they see a forecast or a prediction, they want to know why will this happen? And this is, of course, from a managerial point of view, it's very important to have this interpretability and to understand what's going on. So I think a manager will always be interested in understanding what's going on. And here I see a risk for AI, that it's not going to be able to deliver on these expectations, or that it comes with high risks and weaknesses in that regard. But if we, for example, talk about neural networks, I mean, and if we then take these risks again, lower interpretability and risk of overfitting, then it can still be a very, very attractive tool for example, systems, supply chains, business models, where the history, so the past, is a very good indicator for the future. So if it is a for example a value stream, a supply chain network, a production system that in the past, the data from the past is describes the system very good for in the future also. It's a very good prediction for the future. If we talk about, for example, the variance of the production mix, if we talk about total throughput and total volumes and these kinds of things, then it might still be then something like a neural network is still a very good solution, because the data for the future will be very similar to the training data that was used. So I don't think it's that easy that to say that there's a high risk of overfitting and low interpretability, and because of that, AI doesn't have a chance to be fully accepted. I think there's a chance of AI being fully accepted, but maybe not in all types of industry or all types of business.
Okay, thank you. And now, if we look at the company, what do you think are the requirements that the company should have or to reach in order to be able to guarantee the use of AI? And also, what requirements should the supply chain management should have?
Yeah, if we talk about supply chain management and also sustainability related to artificial intelligence, I mean, the first thing management should do is have their KPIs in order, and also to have sustainability reflected in the KPIs, because otherwise artificial intelligence projects will not have any impact on sustainability. And the second thing is, I think, to have the data available, to have the systems available to store all of this data, but because usually artificial intelligence solutions, they require a lot of data, a lot of training data. And it's also the motivation behind artificial intelligence is that you have a lot of data available. So this is the second thing they need to focus on. And then they need to hire the right people. So they probably need data scientists on the team that are able to assess which type of machine learning algorithm, which type of artificial intelligence method is the right one for the situation that the company is facing. And that's probably the biggest challenge, is to find these people and to find the data scientists that are going to be implementing artificial intelligence in the respective enterprise.
Okay, thank you. Thank you very much. So then we go to the last question, where if we look at it in a scale from 1 to 10, where 1 is a very low impact and 10 is very high impact. If you should choose a number, what would you say? How much does the use of AI and supply chain management helps to reach the ecological sustainability, and why?
The way I use
also, sorry. Also, like if you compare the goals with the use of usual technologies, if you compare the use of AI, then how would you say, does it help or does it not help? And how much is the impact from 1 to 10?
I would say that, I mean, the way I use artificial intelligence is to support existing methodologies. So support, for example, scheduling algorithm built with integer program or constraint program. Support simulation study using discrete event simulation, or implement artificial intelligence in a discrete event simulation model. So the way I work with artificial intelligence is not that I use artificial intelligence itself. I rather use it to support traditional or conventional methods, like, for example, discrete event simulation. And here I see the possibility of AI increasing efficiency and also effectiveness. So I would say 20-30%, so in that range, 2 to 3 as the score I would give to artificial intelligence.
Okay, so that was also the last question of the interview. Thank you very much for your insights. It was very interesting talking to you. Also, like the use cases by using reinforcement learning, which is very rare. Yes, I'm very thankful for your time. Thank you.
Thank you too. Thank you very much for this interview.